Bismillahirrahmanirrahim. Assalamu alaikum. My dear students, I hope you all are doing well. Today we will start a new chapter, new topic for the students of SSC and HSC both, and also for the O levels and N level students. Here actually we will discuss some basic concepts that are used in our chemistry calculation. So let's start for the basic topics that will be very much helpful for you to do the calculation of your maths and solving different problems, inshallah. Okay. So units of concentrations, units of measuring concentration, units of concentrations. So what are they? Usually we use percentage concentration, then we use molarity, then we use molality, then we use normality, then we also use ppm. Now my dear students, these are usually used units for measuring our concentration for the calculation of chemistry, especially in our quantitative chemistry. Okay, now we will start first percentage concentration. What is the percentage concentration? Look, my dear student, percentage concentration. What is that? The amount of solute, here the solute may be present in gram or maybe in ml. So solute cannot be all the time solid, it may be in liquid condition also. So solute can be dissolved in gram or ml. The amount of solute dissolved in 100 parts, it may be in gram or ml, 100 parts of a solution is called percentage concentration. Now let's take example, my dear students. For example, one question: if 5 gram sodium hydroxide is dissolved in 300 ml solution, then what will be the percentage concentration? Here W by V, W means weight, V means volume, and I will also make it more discussion about this W by V. Okay, what will be the percentage concentration? Wait, my dear student. Now, if we want to solve this math, we can do it through the manual calculation and also your formula. So firstly, we will do the manual calculation. Then from this manual calculation, we can derive the formula. Okay. Now, solve. So what is the solve? 300 ml solution contains 5 gram NaOH. So 1 ml solution contains 5 by 100, 5 by 300. Now 100 ml contains 5 into 100, then divided by 300. Now here result will be 5 here 3, that is 5 by 3%, right? 5 by 3%. So look at the board, my dear student. So if we do it divide, so it will be what? 5 by 3, that is 1.66. okay, so we can also do it as 1.66 percent. So my dear student, so what is the formula here? This 5 is given mass, this 300 is the given volume, and this 100 comes for percentage concentration. Okay, now we can make a formula from this solution. Okay, look at here, look at here. So take this, now come here, percentage concentration, W by V, percentage concentration, W by V. Okay, so here your solid is given in mass unit, that is in gram unit, and your given volume is ml. Okay, so what should be the formula? Percentage concentration equal to, we can write now, here 5 is given mass, mass of the solute, mass of the solute, mass of the solute, solute in gram, divided by volume of the solution, volume of the solution in ml, multiplied by this 100. So we can write here 100 or 10 square, whatever. So this is the percentage concentration, W by V. Here W means what? Weight. And here V means what? Volume. So here percentage concentration means the amount of solute dissolved in every 100 parts of the solution. So here the parts of the solution is counted in the ml unit or volume unit. So 300 ml solution contains is 5 gram in which 1 ml contains 5 by 300. Now every 100 ml, so listen to me, every 100 ml. So we are considering the parts of the solution in every 100 ml or every 100 gram, like this. Okay, now percentage concentration, W by W can also be written. So percentage concentration, W by W, what will be the expression here? So mass of the solute, mass of the solute in gram divided by mass of the solution, mass of the solution in gram also, and now multiplied by 100. Similarly, if we do another example, another expression like this, percentage of V by V, volume by volume. So what will be the expression here? Volume of the solute, volume of the solute in ml divided by volume of the solution in ml, my dear student, multiplied by 100. So these are the three category or three types of expression your percentage concentration. So my dear student, look at here, we can express your percentage concentration units in this three way. Now what should be the example of these types of concentration? Now this is the formula. Now we will discuss the three examples related to this expression. Okay, now For example, percentage concentration. We can express percentage concentration W by V. For example, 5% sodium, 5% W by V sodium hydroxide means 5 gram sodium hydroxide is dissolved in every 100 ml solution. So look at here, my dear student. 5% W by V means 5 gram sodium hydroxide is dissolved in every 100 ml solution. It means your solution volume may be 1 liter, 2 liter, 2000 ml, 3000 ml. It is a material. Material is what? 5% W by V is written on your container. For example, this is a container and here it is written 5% W by V sodium hydroxide, for example. It means your total solution volume may be 1 liter, 2 liter, 500 liter, 5 liter, it is the material. But if it is written 5% W by V, it means its concentration. It means its concentration is what? 5% W by V means your 5 gram sodium hydroxide is dissolved in 5 gram sodium hydroxide is dissolved in every 100 ml solution. It means if you do analysis, then every 100 ml contains this 5 gram of sodium hydroxide. This is the meanings of your 5% W by V. So if we write another example, percentage W by W. For example, this same example, 5% W by W sodium hydroxide. It means what? It means 5 gram NaOH is dissolved in every 100 gram of the solution. It means here solution is now expressed in gram, that is mass unit. So here solution parts is measured in ml or volume, and here it is measured in gram. Okay. Now if you write like this, percentage of V by V, then 5% vinegar or V by V ethanoic acid or ethanol. Ethanol means 5 ml ethanol is dissolved in every 100 ml solution. That means here 5 ml ethanol and 95 ml is water. Here 5 gram is sodium hydroxide and 95 gram is what? Water. So we have to think that here percentage can be expressed in this 3 way. I think so these examples are clear to you now. Now we'll discuss about the next unit. Next unit, now we will discuss about molarity. Molarity. So what is the definition of this molarity? At particular temperature, the number of mole of a substance dissolved in every 1 liter solution is called molarity or molar concentration. Now, how can we understand this definition? Okay, now let's take an example. For example, 10 mole sodium hydroxide is dissolved in 5-liter solution. Then what will be the molarity? Okay, this is our question now. Now we can solve it. Now first manual method, then we'll take a formula. Now this is the solution. 5-liter solution contains 10 mole NaOH. So 1 liter solution contains 10 by 5. Here it is mole and it is what, liter. So 2 mole per liter. Look at here, my dear student. 2 mole per liter. This is the molarity or molar concentration. So look at here, my dear student. 1 liter solution has 2 mole. It means every 1 liter solution has 2 mole. So this is the molarity. So what is molarity definition? The number of moles dissolved in every 1 liter. So mole per liter can also be written as molar, capital M. So mole per liter can be replaced by only M, capital M. Okay. Now we'll make a formula. Look at here. Look at here. We can make a formula. Okay. Come here. Here 10 by 5. This is 10 by 5. Molarity. Molarity. S symbolized by S is used to symbolize the molarity. Okay. Now here 10 mole and here 5 liter. Again here 10 mole and here 5 liter. So we can write here mole number. Here mole number and here volume. So if we divide the given mole number, or after converting the mass into moles or mole number divided by volume in liter unit. Of course, you have to remember that here volume is in liter unit. So mole number, if it is symbolized by N, volume is V. So we can write S equal to N by V. So this is our shortest formula of your molarity. Now, again N by V. N is mole number, V is volume, and here volume V is present in liter unit. Now, next step for this formula, and this is very much usable formula. Okay. Now, conversion of mass. Conversion of mass into moles. Look at here. Question. What is the mole number? What is the mole number for 180 gram of H2O? Okay. You know that molecular mass of your H2O is 1 into 2 plus 16 gram, that is what, 18 gram per mole. That means every mole having 18 gram for water. So very simple, 18 gram equal 18 gram H2O means 1 mole H2O. Okay. So 1 gram H2O equal to 1 by 18 mole. So 180 gram H2O will be 180 divided by 18. So it will be 10 mole. So look at here, my dear student. So we can make a formula from this. Okay, mole number calculation. Look at here. So mole number calculation. Mole number calculation. mole number. So mole number N equal to here given mass and 180 was given mass, so it should be given mass, and this is your what? Molecular mass. Molecular mass. So given mass, if it is symbolized by W and here capital M, so you can write mole number N equal to W by M. So N equal to W by M is the mole number. So mole number can be find out using this formula. Dear student, now this mole number can be used in the previous formula. You know that molarity S equal to N by V. So here putting the values of N, we can write W by M, and here it is V, and under this V 1 is present. So W by M into 1 by V, so it is W by M into V. So this is another formula for molarity from S equal to N by V to S equal to W by MV. So here again I'm saying that here V is in liter unit, but you know that 1 liter equal to 1000 ml or 1000 cm cube. So if we want to convert this volume liter to ml, so what will be the formula? So formula will be S equal to 1000 W by M into V. Now, my dear student, both are the same formula and same answer will be prepared from this, but here V is in ml or cubic centimeter, and W is here in gram unit, and molecular mass, you know that gram per mole as it is, and here it is molarity, there is mole per liter. This is okay, and here everything is same, only volume is here in liter. So in between these two formula there is no basic difference, same formula, but here volume is in liter, but here is the ml or cubic centimeter. You can frequently use both of the formula, and also this S equal to N by V. So from this S equal to N by V, easily you can do interconvert the molarity to mole number to molarity, whatever, you can easily find out this. Okay, now we can go to the next step. So maths question, what is the molarity of 300 gram calcium carbonate, you know? So calcium carbonate molecular weight we can easily find out 40, 12, 16 multiplied by 3, so it is 100 gram, or that is what, 1 mole. Okay, so you know that molarity is what? Mole number can we find out? Given mass by what? Molecular mass. Your given mass is what? 300 gram, and molecular weight is what? 100. That is your 3 mole. Now, if you find out molarity of 300 gram calcium carbonate in, for example, 2 liter solution. Okay, so here volume is what? 2 liter. So you know that S equal to N by V. So here mole number is 3 and volume is what? 2 liter. So 3 by 2. So here answer will be 3 by 2. 3 divided by 2. That is 1.5. 1.5 mole per liter or 1.5 molar. Okay. So the thing is that this is the mole number and this is the volume in liter unit. So you can easily do your math using this formula. Okay. Now for the next formula, for example, if you do it in this way, is equal to 1000 W by mv, same is same. So 1000 W here is what? 300 gram. Molecular mass is 100 and volume is what? 2 liter, and here volume is what again? Liter. So you can write here 2 liter equal to 2000 ml. So here 2, here is 3, and here is also 2. So 3 by 2 again 1.5 molar. So this is the same answer produced from these two formula. Okay. So you can use your molarity is equal to N by V and simultaneously this formula. So that you can use any of this, which is very much easier to you, but it can be done in this way. Okay. Now the next question. 600 ml 0.5 molar sodium carbonate, and here 500 ml 0.3 molar HCl. Okay, now you can do anything. Anything means a mole number, molecule number. Okay, for example, here solution. A question: how many moles and molecules of Na2CO3 and HCl are present in the above stem? It's very simple math, so you can do it. For example, here it is A and here it is B. So for A, you can write is equal to N by V. Here S is what? 0.5 and N can be find out. 600 ml means your 0.6. So N equal to 0.5 into 0.6. So here the mole number will be 0.3 mole. Okay. Now what will be the molecule number? You know that 1 mole has 6.023 into 10 to the power 23. So 0.3 mole is what? So we know that 1 mole Na2CO3 equal to 6.023 into 10 to the power 23. So this mole sodium carbonate is 0.3 into 6.023 into 10 to the power 23. So this multiplication will get the answer. For example, what is the answer here? 6.023 into 10 to the power 23. Okay. So here the answer is 1.8 into 10 to the 23. Sorry, 1.8 is 1.8 into 10 to the power 23 molecules. Okay. So this is the very much easiest way to find out the number of mole and molecules. Similarly, the second question, we can do it. For B, N equal to S into V. Now, we can do it in the shortcut way, 0.3 into 0.5, because 500 ml into liter is 0.5, so 0.15 mole. So, mole is answer is here. Now, molecule is 0.15 multiplied by alphabetic number 6.023 into 10 to the power 23. So, it will make the final answer, molecules. Okay. So, my dear students, look at here. So, today we have discussed just very initial concept of your units. So, just first we have discussed your percentage concentration, then molarity. In the next classes, we will discuss more details about their maths and next terms. Okay. So till then, Allah Hafiz. See you in the next class, and keep in touch in our channel Chemistry Unlocked. Assalamu alaikum.